Alrighty then, corn children. We have a summary lesson on sketching rational functions. Now, I am assuming that you have watched the videos on horizontal asymptotes. You have done the lesson with dominant terms. You have done the lesson of vertical asymptotes, and you've watched that video on point discontinuity, because today we're going to put it all together. All right, so here's our rational function for this video. Take a minute, write it down. All right, you'll notice it is not factored. In order to do curve sketching, we're going to find a ton of stuff, and so I'm going to start with what can I find easily when it is not factored. So this is our unfactored form. First up, y-intercept, piece of cake. The y-intercept is the point on the y-axis, so the x-coordinate is automatically 0. So if I fill in 0 here, 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 and here, the only terms left are going to be -9/12. Look at that. I reduce that down and I get -3/4. Presto, y-intercept. Boom. Next thing, in unfactored form, we can find the horizontal asymptote. How do we find the horizontal asymptote? We take the limit as x approaches infinity. There are going to be two different limits in this problem, and they are handled differently. This is x going to infinity. We do this through those dominant terms. If you need to, watch that video again. I see here in the numerator the dominant term is x squared. In the denominator the dominant term is 1x squared. These are equally dominant. When they are equally dominant, the answer is the coefficients. The answer to this infinite limit is 2. That answer is also your horizontal asymptote. All right, that's what we get out of the unfactored version. Again, pause if I'm going really fast, because I know I am. Next up, we're going to factor this thing. What? What? Yep, there it is, the factored version. Check it yourself if you'd like to. Now, do not cancel it. There's information out of all the factors before canceling. Yes, I'm aware those will cancel. Just don't do it yet. All right, first up, we can find the x-intercept really quickly and efficiently. X-intercepts have a height of 0. So the question is, what number will cause this fraction to equal 0? Fractions will equal 0 when the numerator is 0, but the denominator is not 0. So I want to know what's going to make the numerator 0 but won't also cause the denominator to be 0. Well, this is the only factor in the top that is not also in the bottom. So I ask, what will make this equal 0? I'm pretty sure I can solve that, and I get -3/2. Set this equal to 0, solve. Alrighty, still in the factored version. Next up, vertical asymptotes. If you go back to the lesson on vertical asymptotes, we're looking for the x value. It's like the x-intercept upside down that will make it not 0 in the top, but 0 in the bottom. Not 0/0. What makes the denominator only 0? Well, that would be the value of 4. Check it out. If you fill in 4, you will get not 0, and you get 11/0. All right? So, yeah. 4. That's it. That one's so easy. All right. Next, this is the tricky one, the point discontinuity. Point discontinuities begin with what happens when you get 0/0. So when I look at this, I ask myself, what's going to make both the numerator and the denominator 0? And we see that 3 will make both the top and the bottom 0. So in order to get the answer, what we're asking is, we know at 3 it's broken, but we want to know what happens as we approach 3. So it is 3 that makes 0/0. The limit as x approaches 3. This is not a dominant term game. This would be direct substitution, which failed us, factor, now the canceling, and the plugging 3 back in. When we plug 3 back in, we get 9/3. negative 1. And here's what this means. The function is undefined. There's no point there. There's no dot. But we are approaching the coordinates, point discontinuity, that's a P, of 3, negative 9. Okay, corn children. Now, here's what we're going to do. We're going to take all of this information, put it all together, and sketch this. No calculator. Now, of course, you can verify all of it with a calculator, but we're going to do it without a calculator. All right, so from the top, we have a y-intercept of 0, negative 3/4. Easy enough. We have a horizontal asymptote at y equals 2. Okay, that was simple. We have an x-intercept of negative 3/2, that's negative 1.5, 0, that's easy. We have a vertical asymptote at 4. Now, we have a point discontinuity at 3, negative 9. Here's how we do this. You draw a hole. Now, the graph has to go towards the hole. It acts like a point, but it's not a point. It's missing. All right, so here's what I know. When we go out towards infinity, that-a-way, we need to approach the asymptote. I have 2 dots here. When I approach this asymptote, I have to go either up to infinity or down to infinity. Well, look, there's 2 dots and a hole. Approach the asymptote, go through the dots, head towards the hole, go down to infinity. This left side of the vertical, pretend I touch all those. The left side of the vertical asymptote over here is pretty straightforward. Now what about the right side of the vertical asymptote? What the heck are we supposed to do over here? We don't have any dots, we don't have any holes, we don't have anything. Yeah, we don't have any dots. Specifically, we don't have any more x-intercepts. What? We don't have any x-intercepts. So is it possible for me to go down to negative infinity and then come over towards the horizontal asymptote? Well, no, I would cross the x-axis, and we don't have any x-intercepts. Therefore, on the right, we have to go up to infinity and then flatten out along the other asymptote. That, ladies and gentlemen, is a crash course in curve sketching. I would stop and go back through this slowly and carefully. I would take notes, because that's how I roll. Booyah!